Okay, properties of logarithms. This goes with section 7.5 in your book. There's sometimes people call these the laws of logs. There's three properties to know and names that go with each. There's the product property, which is this. So if you have the log base b of two things multiplied together, m times n, we're just picking any variables, then that will be equivalent to the log base b of m plus the log base b of n. So you can break it into two different log expressions, and you can go either way. And we'll do examples using these in a minute. There's so that's the product. There's the quotient property that's like this. If you have log base b of m over n, then you can write it as log base b of m. What do you think I'm going to put here? Yes, you see the pattern. Log base b of n. So there's the product property, the quotient property, and then there's the power. This is the most important one. This we'll use. Remember when we started the unit, I said that the reason we need logs is to solve exponential equations when the variable is in the exponent. That's going to be like a fill-in-the-blank question on the test. So this power property, log base b of m, when it's raised to the n power, okay? And so when we're trying to solve equations and we don't know what the exponent is, this lets us solve it. The n, this that looks like the exponent, can be brought down as the coefficient. Log base b of m. So you can move this exponent, because of the way logs work, you can move this exponent to the front to be the coefficient. And that's usually the direction we go, so that we can solve equations. And that's the one we'll use most often. So let's do some examples of these three properties, and then we'll look at the change of base formula as well. So let's say we have expand. We can use these laws to expand or condense expressions. So let's say I have log of 3x to the 4. Okay, and I want to just write it, I want to expand it. So first I would use the product property to divide this up. There's two things multiplied together. There's 3 and there's x to the 4th. So you would just separate it out. That would be log 3 plus log x to the 4. We're trying to expand it, and usually we simplify, but we're doing the opposite way. And why? Just to practice using these properties. And then the exponent, that 4 was an exponent, it becomes the coefficient like that. So it'd be 4 log x, and that would be your answer, log 3 plus 4 log x. So let's try this. Last expand example, log base 7 of 3x squared over 5y cubed. Log base 7 of 3x squared over 5y cubed. And we're just going to expand it to practice using these properties. So the first thing, we have division, so we separate it out into two different log expressions, and we use subtraction. So it's log base 7 of 3x squared minus log, now we have two separate log expressions, log base 7 of 5y cubed. So we use, what property do we just use of the 3 to go from this to that? Good, quotient property, nice. And then we're going to take this is still two things multiplied together, so this is log base 7 of 3 plus log base 7 of x squared. I just took this one expression and divided it up further, and then this one minus, we also have to work with this, So log base 7 of 5 plus, because we're separating that out, log base 7 of y cubed. Okay, and then we are going to, we're almost there, so this is expanded as much as we can. Log base 7 of 3, that stays. What happens to the exponent 2? If we use the power property, it goes where? To the front, so plus 2 log base 7 of x. Here we distribute the minus, so minus log base 7 of 5. And we have to distribute the negative and the 3 as the exponent comes down, so minus 3 log base 7 of y. That's a base 7, log base 7 of y. So they don't get any harder than that for expanding. So that is done. Now we're going to go the preferred direction, which is to condense. So I'm going to move on to the next part. So let's say, so now we're going to do condense these. So let's try, condense is simplified. So natural log 4 plus 3 natural log 3 minus natural log of 12. And what was, to review, what's natural log is base, okay, common log is base 10, natural log is base e. Yeah, so all the same properties that we just learned apply the same way with natural log. So we are going to make this a nice answer here. We're going to condense this. So we start with anything where we can use the power property. So we're going to move this 3 up to be the exponent. So we get natural log 4 plus natural log of 3 raised to the third power. Raised to the third power, because remember this coefficient becomes the exponent, minus natural log 12. I'm just doing one step at a time. Equals, and now what law can we use to combine these when we have addition in two separate log expressions? Go back to the properties. Which property? Good, the product property. Nice. We just go in the reverse direction. So it's natural log 4 times 3 cubed. We condensed it into one expression, minus natural log of 12 equals. We just do this on our calculator. Be sure you do the right order of operations. You would do the exponent and then multiply. That's just a number, which is, it's okay to use your calculator, 108 minus natural log 12. And then which law do we use to make this into one log expression? The nice quotient property. So we just divide these numbers, 108 over 12, and it's okay to use your calculator. You get natural log 9, and we're going to leave it like that. We condensed it. Notice we started with an expression with 3 different logs in it, and we ended up with just 1. And that's the best we can do. We can't do that in our head. You would just find the button on your calculator, and the last set of problems in your homework tonight, 84 to 91, are all using your calculator to evaluate things. So don't think there's a bunch of word problems at the end. There aren't. Natural log 8 plus 2 natural log 5 minus natural log 10. This will be our last condense example, and then we'll move on. So, well, do we need another of these, or are we okay? It really works the same way. Okay, great, awesome. Let's move on to, this is better, to evaluate. This is our last skill, and is also super important, and this leads us to the change of base formula. So we did expand, condense, evaluate. Now we're doing we did expand, condense, now we're doing evaluate. So log base 5 of 8. Okay, so log base 5 of 8. So you've noticed, just make this a little bit bigger here. So you've noticed that there is no base 5 button on your calculator. There is no base 5 button. But tell me in a sentence what this means, what it's asking when it says log base 5 of 8. Awesome. 5 to the what power equals 8. You should be able to write out that expression. That's what in logarithmic, this is exponential. You should be able to go back and forth. Now, unfortunately, we can't do 5 to a power, but we know it's a little more than 1, but we can't do that in our head. But what we can do to solve this is new, and I'll write the steps what we're doing, is take the log of each side, so you'll go, that's fair, right? We've been working with equations for a while. As long as you do the same thing to each side, then there's not a problem. I want to solve this equation, that's my goal. This is what I started out the very first unit asking you how you would solve this, and we didn't have a way to do it. So you go like this. You're allowed to take the log of both sides like that. And then here's key, use which of the 3 properties are we going to use to solve this? Yeah, use the power property that we just learned, which is why it's the most important, to bring this exponent down to the front. X log 5 equals log 8. And wow, we're almost there. We're going to be able to use our calculator in a second. Because, right, we can solve this now. Now that x is not an exponent, but x is just a number right in front of this, we can just divide both sides by this constant. Log 5 is a number on your calculator that it will do. There is a button for that. And the answer to this question, if you use your calculator, can be found by taking the log of 8 and dividing by the log of 5. And you will get that number that's if you raise 5 to that power, you get 8. And so it's log 8 over log 5. And when you do that on your calculator correctly, you should get 1.29, and we'll always use 2 places past the decimal for these. So you'll get about 1.29. So we're gonna do one more example of the same thing because it's the most important. So let's try this. So example 5, log base 8 of 14. Okay? So you try log base 8 of 14. Okay, I tried to pause it, that didn't happen. So we're asking 8 to the what power equals 14. So what do we do next? Good. Take the log of each side. Log 8 to the x equals log 14. And then? And then we use the power property, x log 8 equals log 14. And last step, just this, what do I do? Good. Divide both sides by this constant, log 8. So you will get about 1.3, 1.27, we'll leave it like that. And so to wrap up, there is a formula. Do you see the pattern for, like, look at the original and look at what the answer turns out to be? It's always going to be like that. So there's something called the change of base formula. So this is the formula that you do not need to memorize because you understand how it works. if you have log base b of a, that will be log a over log b, and that's the change of base formula. And that always works for all of these.